Hello and welcome to this presentation about the Department of Chemistry at the University of Bath. I am Dan Pantos and I am the admissions tutor for chemistry at the University of Bath. The Department of Chemistry in Bath is offering degrees in chemistry at BSc and MChem level, chemistry for drug discovery at BSc and MChem level, and also chemistry with management at BSc and MSci level. We have a common entry, which allows us to have flexible transfer between the courses. I'll tell you more about this a little bit later. The point is that whatever offer you get from us, it will be the same regardless what you have filled in or what you will fill in on your UCAS form, be it BSc, MChem, MSci, and any of these courses. So I'm going to tell you a little bit about why should anybody do chemistry, really. I'll tell you also what it's like to do chemistry in Bath, and also, of course, what it's like to study chemistry at university level. So let's start with the first bit. Why should anybody do chemistry? Well, because it's interesting, but I mean, I've been a practicing chemist for 20 plus years, so of course I find it interesting, and of course I will say that it's the best science. But jokes aside, chemistry is a central science. Why do I say that? Because chemistry is influencing pharmacology and biology, obviously through all the medicines that we're making and we're taking, right? A chemist has synthesized every single medicine that has been administered to patients. And therefore, the links with pharmacology and the biological world are quite obvious. In terms of environmental science, we are working very hard to try to develop processes that are environmentally friendly, that we can make everything that we need for our everyday life in an environmentally friendly way, to generate electricity, to generate energy in an environmentally friendly way. With material science, the links are quite obvious, as are with physics and maths and computing as well, and engineering, because if you think about it, absolutely everything around you that has a material has some chemicals inside that have been synthesized by a chemist. This starts with this shirt, for example, and it goes to the airplanes, the fuselages, which are composite materials, which chemists, physicists, engineers, mathematicians all came together trying to design and devise a material that's the best that we can make for the purposes that we need. So chemistry is useful. I think that's quite obvious. So back in the day, this is the image for chemistry, right? A big power plant that was polluting, but nowadays chemistry is moving very rapidly towards making, for example, the photovoltaic cells, right? So right now the photovoltaic cells are working around 20% yield or something like that. So only 20% of the solar energy that's hitting them is converting into electricity. How nice would it be if we could up this to, let's say, 30% conversion? Because if we can get that, we can generate more renewable energy. I already alluded that the shirts, the clothes, and everything that has color around you and has been made synthetically has been made by a chemist, because all the dyes and pigments that are in clothes, in furniture, on the walls and everything, they have been made by chemists that knew how to modify the molecules in order to achieve a blue, a purple, a green, or whatever color we may want. I will also say that Team Peak would have not gone to space without chemists. And this is true for all the astronauts, not just for Team Peak, because the spacesuit, right? The suit that protects the astronaut from the vacuum of space is a super engineered feat of technology, right? And in there you have 7 layers, each of them designed for a very specific person. For a very specific purpose. All those layers that are in this suit are containing chemicals that have been designed by chemists and synthesized by chemists, along with engineers, material scientists, and so forth and so on. Of course, chemistry is useful because we are making the medicines, right? We get ourselves better when we're poorly. And in this day and age, this is particularly important, right? So here we have Alexander Fleming, who discovered penicillin. Without penicillin, we would be in much worse shape in terms of the healthcare that we enjoy these days. Here we have a photo of Stephanie Kvolek, who was the inventor of Kevlar. Right? So a chemist figured out a way to synthesize a fiber that was stronger than steel. And Kevlar, as probably you all know, protects you from high velocity projectiles. So chemists can protect you from that using this magic of, in this case, was organic chemistry. But chemists can also protect you from the what we call the invisible killer, right? The UV radiation. So everything that you have in a sunscreen, everything that's in there has been made by a chemist, right? And chemists have designed molecules to absorb the UV radiation so that you do not get a high incidence of skin cancer if you like to go sunbathing. So chemistry is very useful. After studying chemistry, you can get a career in research, like Dorothy Hodgkin here, or in industry, or you can do teaching, hopefully not the kind of teaching that these people have done, or you can go into scientific administration, in publication, in journalism, in businesses and financial services. You can go in all these areas because after getting a degree in chemistry from our university, you'll learn how to interpret data, you'll learn how to process data, how to present it, you'll know how to make a intelligible report, how to produce a graph that will explain the data that you have acquired, how to extract information from there, how to write a presentation, how to show it in a written format, in a video format, or in person. Hopefully in person will be the dominant way of presenting things in the near future. So you'll develop your written and oral communication skills. And in the end, all of these, we call them transferable skills because they are not just pertinent to chemistry, they are pertinent to every single walk of life. So I think it's quite obvious why one should do chemistry, because it's interesting and it can teach you a lot of very useful things. So what's chemistry like at university level? Well, you'll do two things. You'll be making stuff, right? Chemistry is an experimental science, and you'll try to find out why the stuff that you made has been formed, how it was formed, and so forth and so on. So you'll try to find why stuff happens. All right. So in terms of making stuff, I have here a very much magnified image of K glass. Now, this K glass is this special glass that's used in environmentally friendly buildings that this type of glass doesn't allow heat to be transported in both directions through it. So it allows heat to go in, but it doesn't allow it to go out. Okay, so how has this been achieved? Well, it's fairly straightforward because you have a piece of glass that has a very thin film of a metal that's incorporated in it. And this thin film is the one that prevents heat to be lost. And that's fantastic. And why do I have it? Because a student that was an undergraduate at the University of Bath was involved in the development of K-glass back in the day, 20 plus years ago, when K-glass was developed at Johnson Matthey. Now, as it happens, that chemist is a professor of inorganic chemistry at the University of Bath. So you'll make stuff, for example, like this metal complex. This is cisplatin, which is still one of the best drugs that we have in fighting cancer. And with understanding how to make things, you'll understand why this molecule, for example, has the property that it has. Because not only that you'll understand how to make it and what the structure is, but you'll start to understand the three-dimensionality of this molecule. So for example, in this representation, the green spheres represent the chlorine atoms, the dark blue spheres represent the nitrogen atoms, and the light blue sphere represents the platinum atoms, with the hydrogen atoms being the small white spheres in the back. So you immediately will understand that this molecule has planarity, but at the same time that the ammonia groups in the back can rotate around the platinum ammonia bond, which gives it a three-dimensionality because they are in the end tetrahedra that are all linked to this platinum center. So like that, you'll understand why, for example, it can interact with DNA, why it can bind to the nitrogens on your nucleobases, and why, of course, the cisplatin triggers apoptosis, which is the cellular death in tumors. Okay, so you'll be making this kind of stuff, and this is inorganic chemistry, but also you'll be making organic molecules. I'm an organic chemist, and I love it. I mean, you will not be making a molecule of this size. This is palytoxin. It's a very large molecule. And this molecule, actually, it has been in the news last year because a family had a coral in their fish tank, and they decided to clean it, thinking that the coral was dead. Actually, the coral was alive. And of course, during the cleaning process, the coral got stressed out, and therefore, it released nanograms of this palytoxin. What happened was that these nanograms were strong enough and poisonous enough to get this family poorly. Now, they recovered and everything is okay. However, this is the power of this type of organic molecules. And this is something that we're trying to understand. We're trying to learn from nature. And we're trying to understand how can we use this for our benefit. Of course, not as toxin, but as drugs. A lot of the drugs that we're using at the moment are derivatives from natural compounds. So, as I said, you will not be making this in the lab. This can take research groups quite a number of years to make. But you'll be doing this kind of stuff in the lab, for example. You'll be doing first-year chemistry, like this carbonyl chemistry. You'll be doing second-year chemistry, so you'll be making heterocycles or nucleophilic substitution or aromatic chemistry. All of this is organic synthesis, and you would be making this type of reactions in the lab. Now, you will not make this exact molecule because this is a precursor for a drug. But why I put this here is because this molecule, when you look at the like firsthand, you look at it and you say, okay, this molecule is flat. But actually, with molecular modeling, with computational chemistry, which you will be learning at the University of Bath, you'll understand that this molecule actually, it's not planar, that there is a kink in the molecule, and this kink here, right where the sulfur atom is, which is represented with this greenish yellow sphere on the molecular model on the right-hand side. This gives this three-dimensionality to the structure, and also you'll be able to represent the molecule like that, and you start understanding a little bit better the structure and the properties of the molecule. Now, this is sildenafil, which is a drug that's actually quite funny because it was developed for a totally different purpose, and yet because the scientists had an open mind and realized that, look, it doesn't do what we wanted, but it does something else. It made quite a lot of money for Pfizer. But that's besides the point that in fact, that made a lot of money. What's important is here from the whole story is that the scientists had an open mind. And as a chemist, you'll have to keep an open mind because not all the reactions that you will be doing in your life as a chemist will work. And you'll have to try to understand why that is. And if they work in a different way, we'll teach you how to exploit that and how to develop your skills to say, all right, it didn't do what I wanted, but it may be doing something else interesting. So that's about making stuff, but also you'll try to find out why stuff happens. So the picture in the background here, it's our flow NMR suite, which allows us to monitor what's happening with reactions in real time, right? So we can take NMR spectra, which inform us about the structure of the molecules that are present in the reaction mixture live. And then you could be doing this kind of stuff and try to understand the reaction mechanisms and everything. Also, you could be doing something else. Now, in the photo here, I have Professor Barbara Kashprit-Horton, and Barbara and her research group is doing something amazing. They are looking at wastewater. Now, in first instance, you might say, oh, that's not the nicest thing to do. However, it's very, very useful. because by looking at wastewater, they can figure out a lot of things. They can figure out, for example, if there has been a chemical spill or a medicine spill or something that quite funny and came out of their research in the past few years. They were able to tell when the illegal drugs have been used more during a week. So what does that mean? So let's put it this way. The police knew that on Friday and Saturday, there is a larger consumption of illegal drugs in pretty much all the big cities around the world. But this was anecdotal evidence. Barbara, with her team and their colleagues around the world, were able to devise a method that analyzed the wastewater for metabolites of illegal drugs. And indeed, after analyzing the wastewater from London, Amsterdam, Munich, from Bath, from Bristol, from everywhere, right? They saw spikes in the metabolites for illegal drugs, for LSD or cocaine, on Friday and Saturday. So they were able to put numbers down and say, indeed, on Friday and Saturday, you have a much larger consumption of illegal drugs than during the week. And also they were able to track the new illegal drugs that were appearing on the market, right? So this is quite powerful. And how were they able to do this? Well, they have HPLCs, they have mass spectrometers, and with all these fantastic modern techniques, they were able to analyze the wastewater for these very minute traces of metabolites. Now, this is what Professor Barbara Kastrik-Horden is doing in her research group, and you could do research in your final year in her group if that's what interests you. Or, for example, another research that's happening in the department, this time in Dr. Asel Sarbaeva's lab, is the research that's trying to build a molecular, if you'd like, spacesuit around vaccines. Now, why would anybody do that? Because we're trying to eliminate sad pictures like the one here with a camel that has on its back solar panels, and the solar panels are generating the electricity that are powering the two little mini fridges that are on the back of the camel as well. Now, all the vaccines and most of modern medicine is very sensitive to temperature. This means that we need to have a cold chain. What does this mean? It means that once they have been synthesized, they need to be kept in at low temperatures, usually around 4 degrees, like what we have in a regular fridge. So all these vaccines and modern medicines, they need to be kept cold. But it's very difficult to keep them cold throughout their transport, right? We are very lucky because you have lorries that are these cooled lorries, right? And then once the manufacturers package the vaccine, then it's kept cold, it's in a cold lorry, then it gets to your GP, it's kept in the fridge, and then it's administered. Okay, that's fine. But what happens if you want to deliver this vaccine into a remote area? What happens if the lorry breaks down? This is all very expensive because the vaccines will break down because if they reach higher temperatures, because it costs a lot of money to ensure that you have 4 degrees, let's say, in an airplane, in a lorry, on the back of a camel, and so forth and so on. And besides the financial cost, there is the human cost, because you deliver these vaccines or these medicines because people need them. Now, if something happened in the cold chain, if there was a break in the cold chain and the vaccine reached room temperature or even higher temperatures and they decomposed, you might be administering something that will do harm rather than good. Now, we don't want that. So in Asel's group, in Dr. Sarbaeva's group, they are trying to build this molecular spacesuit for the vaccines so they can be kept at room temperature without degrading. That would be great if we can achieve that, because then we eliminate the cold chain. And that's fantastic because we can deliver all these fantastic medicines anywhere on the planet without worrying that they have decomposed. And of course, once they are at the place of delivery, or like the GP that's going to administer the vaccine, the GP will just take the molecule out of the spacesuit or administer it like that if it's a molecular spacesuit that can be digested, and then there you go, you have your cure or your vaccine. So that's another type of research that you can do in your final year in our department. And I will tell you more about type of research that are happening in our department in a few more slides. Now, why should you do chemistry at the University of Bath? Well, because we have a very flexible course. And this is what I alluded at in the beginning. There is a lot of variety, so there are lots of optionals that you can choose from. And you can move between one program and another seamlessly. We are offering industrial placement that is year-long, and we are offering also study abroad options. We have high-quality labs where you will spend time with really very well-trained teachers that will be there to support you in doing the experiments, in understanding what's going on. And of course, not just in the labs. We're trying to do a very good job in lecturing and in tutorials and in the workshops as well. But overall, we have a very supportive environment for all of our students. And as I alluded to already, we are a department that praises itself in the type of research that we do. So, as I said earlier, we are offering this type of degrees. So chemistry, chemistry for drug discovery, and chemistry with management, both at bachelor's and master's level. So when I say that we have common entry, it means that the offer that you will get will allow you to get into BSc or MChem the same way. Now, the flexible transfer is related to what happens to you if you decide to come to Bath as, let's say, a BSc chemist, and then after a couple of months you say, I really like this chemistry with management program. Can I transfer? The answer is yes. Up till the beginning of your second year, you just fill in an A4 form that you take to the student office and you say, okay, I want to transfer from BSc chemistry to chemistry with management at MSci level. And this is just one example because you can do all these transfers however you want. And you can do that without absolutely any problems because we have common entry and because all of our students are doing the core units together. The difference between all the programs are the optionals. So we are teaching in lecture theaters, we are teaching in small groups, so those are the tutorials or the workshops, we are teaching in the labs, we are having workshops in the labs, not just in the lecture theaters. You'll be doing computational labs, but you'll be doing also a lot of independent study as well. Now, this is an example for the first year timetable. This is first semester, first year, where you see here that Thursday, you will be in the lab the whole day. The rest of the week, you'll have 3 times a week organic, 3 times a week inorganic, and 3 times a week physical chemistry. And these are the core units. And then the rest, you'll have options, you'll have tutorials, you'll have key skills, and you'll have maths as well. Now, in terms of your options, if you're studying chemistry with management, economics and intro to accounting will already be pre-selected for you in the first year. In the first year for chemistry for drug discovery students, we have chemistry of the cell and drug properties and physiology. And also chemists can choose chemistry of everyday things or green chemistry. We have also as an optional math for chemists in semester 2, and also for extra credit, you can take languages at our excellent language school. Mathematics is not required. We do not have it as an entry requirement for studying chemistry at the University of Bath. So what happens is in the first semester, right at the beginning, there will be a test, and then we'll assess your mathematics skills. If your mathematics skills are good, then you don't have to attend the maths classes in the first semester. But if we feel like you need a brush up, then you will be in mathematics classes taught by chemists for chemists. So there will be my colleagues in physical chemistry or computational chemistry that will teach you the mathematics that is needed for those parts of chemistry. If you're a mathematics buff and you want to continue with maths, that's excellent. You can take the option Maths for Chemistry Semester 2, or you can sit in for extra credit in the mathematics lectures from our excellent mathematics department. Now, in later years, we'll have still core chemistry, and this is throughout year 2, year 3, and year 4, or year 5. And these are consisting of inorganic, organic, and physical chemistry. But as you progress throughout your education, you'll have more and more optionals, and you'll get to study more and more specialisms. I don't think this is a real word, but there you go. So these courses are very specific to a particular interest or to a particular branch of chemistry, right? And you get to choose which ones you want to study. In year 3, you can go on placement, or you can do study abroad, or of course you can stay in Bath, and then you will do core chemistry optionals and a research project. In your final year, you can choose to do research project, or you can become a university ambassador, or you can be involved in public engagement. Now, I'll tell you a little bit about the placements. They're a fantastic opportunity. We've been sending students on placements for over 40 years, right? And so we have a lot of experience. We offer a year-long placement. And this year-long placement is part of your degree. It's integrated, right? So it's the 3rd year in your degree. And you have up till the beginning of your 2nd year to decide whether you want to go on placement or not, okay? Now, why should you go on placement? Because if you go on placement, you learn skills and you'll develop in a way that you cannot develop in any university on this planet. Why? Because you will be able to understand how businesses work. You'll be able to understand how to fit in a lab, into a research lab, into an industrial lab, depending what type of placements you are going to do. So you will enhance your employability. Also, you'll be making money, which is good, right? So you'll earn a salary while you're on placement. And also, you'll be paying about 20% of the university fees for that academic year. These are the employers that have taken students from the University of Bath chemistry in placement in 2019. Every year, this list is expanding or contracting depending on the economic situation and depending on where the students and the type of placement that the students want to go to. So there is a broad variety, and you can have placements in this country. You can have placements abroad as well. When I talk about placements abroad, you can have placements in Europe. You can have placements in Australia, in South Africa, in North America. We had placements in Japan, in South Korea. Depends where you want to go. Okay. If you want to know more, if you want to have more information about placements, please visit our departmental website, and there is a section there about placements, and you'll find all about it there. Now, the placements, as I said, enhance your employability, and they allow you to understand whether you will fit in that type of industry or not. There are students that come from placements and say, yes, this is what I want to do for the rest of my life. There are students that come and say, actually, this is not for me. And that's okay. Both answers are perfect because you figure out before applying for a real job what you want to do. So that's fantastic. You can do, as I said, study abroad, and you have, again, flexibility for deciding whether you want to do this or not up till the beginning of your 2nd year. You can do lectures, research projects, language courses when you're abroad, depending on the programs that the abroad university is offering. There is the possibility of financial support, and we have faculty-wide exchanges. We are sending students in US, Canada, Brazil, France, and all these countries that are presented here on the slide. And some of them are under the Erasmus program, some of them are not on the Erasmus program. So we'll have to see what the government decides with the Erasmus program once the Brexit process has been finalized. In terms of research, as I said, we are a very, very research active department, and every student will be involved in research in one way or another. These are the areas of research that we are offering currently, and plus many, many more. The way how the research project is chosen by the students is happening at the beginning of their final year. There is a poster session where members of staff, like myself, are proposing research projects to the students. The students fill in an online form, making a ranking with their top 3, And for example, last year, 80% of the students got their first choice and 20% of the students got their second choice of research projects, which is fantastic. We are very proud to say that 98% of the research conducted in the department has been judged as world-leading or internationally excellent in the last evaluation of the research conducted in UK universities. So why should you choose Bath? Because we really like to take care of our students, and this is reflected in the 95% satisfaction rate in the latest national student surveys. We are in top 10 in a variety of rankings done by a variety of bodies, which just highlights the quality of our university. And we have fantastic sports and arts facilities on campus, and the student union is just amazing. There are so many clubs and societies. It's just incredible, and they have a lot of support and offering a lot of support for our students. So what is our offer for the 2021 entry? Well, if you're studying 3 sciences at A levels, our offer is AAB with A in chemistry, obviously. If you're studying 2 sciences, one of which is chemistry, then our offer is AAA. And if you're doing Welsh Bac or EPQ and you score, for example, an A in EPQ, then we drop a letter grade from our offer. So the AAB offer becomes ABB, or the AAA offer becomes AAB, right? And in terms of the science subjects, they are the ones listed here at the bottom of the slide. We consider these as science subjects. So if you have one of these plus, let's say, physics and chemistry, then you would be considered as a triple science student, and therefore your offer would be AAB with an A in chemistry and AB in the other 2. If you're doing international baccalaureate, then we expect you to get 36 points overall with 6 points in higher level chemistry. If you're studying in a slightly different format or from a different awarding body, then just please look at our website and you'll find all the information needed there. So chemistry is fun and it's very useful. Chemistry will put you on track for a really fantastic career after university. We have a very flexible course and the UCAS form is not binding. We offer industrial training and a study year abroad, and you will experience really high quality teaching should you come to the University of Bath. So that's it for today. If you have further questions or if you want to know more about it, please go to this website and you'll find there information about our department and all of our offerings. And I'll leave you with a picture from Bath. It's beautiful. It's a really nice place to visit. And hopefully, once the lockdown has eased up and we won't be in lockdown, hopefully we'll be able to welcome you in 1 South, which is the chemistry building on our campus. And hopefully I'll get to read most of yours applications and personal statements and all that. And I'll get to see some of you at the applicant visiting days and then welcome you as students at the University of Bath. Thank you very much. Stay healthy and happy, and hopefully I'll see you. Bye.